we now learn about partial fraction decomposition, for which the setup will always look something like what we see on the screen here. That is, one polynomial function being divided by another. And so if all goes well, by the end of this video you'll have no trouble in showing that this is equal to 1 over x plus 2 plus 1 over x minus 1. But before I work through 3 examples, let me point out 2 important conditions that need to be met for us to be able to write a fraction like this one in this format here. Here they are. First of all, the degree of the polynomial on the numerator needs to be less than the degree of the polynomial on the denominator. And the second condition that's important and needs to be met is that the polynomial on the denominator can be written as a product of its linear factors. And so for the example we see on the screen here, the quadratic that we see here, x squared plus x minus 2, well, that can be rewritten in factored form as x plus 2 times x minus 1. And these 2 linear factors are exactly what we see on the denominators of the 2 fractions we see here. So that second condition is clearly quite important. Last but not least, let me point out that although both of the numerators you see here have a 1 on them, that definitely won't always be the case. And in fact, finding what the numerators need to be can be thought of as the bulk of the work when carrying out partial fraction decomposition. That being said, let's get started and work through 3 examples, each of which gets a little bit more complicated than the previous. So I would recommend watching through this whole lesson. Here we go. For the first example, example 1, we're given this fraction here. We have 3x plus 7 over x squared minus 4. Notice that the degree of the numerator is less than the degree of the denominator, and since x squared minus 4 definitely has 2 real roots, we can use partial fraction decomposition here. Indeed, I have no doubt that you're comfortable with me writing x squared minus 4 equals to x minus 2 times x plus 2. And so using this result, we can go ahead and state that this whole fraction is the same thing as 3x plus 7 over x minus 2 times x plus 2. Okay, now the whole idea is to use these 2 linear factors to state that this entire fraction is equal to some number which we'll call a over the first linear factor, x minus 2, plus another number which we'll call b over the second factor, x plus 2. And so the whole idea now is that we need to figure out what the numbers a and b are. And there are a couple of ways of doing this, but I'll show you the way that I think is the most efficient. Here it is. I'll go ahead and multiply the entire equation, so the left-hand side and the right-hand side, by the product x minus 2 times x plus 2. And so perhaps I'll write that. I'll multiply the whole thing by x minus 2 times x plus 2. Now in doing so, hopefully it's clear that the left-hand side becomes 3x plus 7. And on the right-hand side, well, let's see, when we multiply this first fraction, a over x minus 2, by x minus 2 times x plus 2, the x minus 2's will cancel each other out, and we'll be left with a times x plus 2. As for the second term we have on the right-hand side, something similar will happen. We'll have b over x plus 2 times x minus 2 times x plus 2, and this time the x plus 2's will cancel each other out, and we're left with b times x minus 2. And now to find what a and b are, I'll work in 2 steps. The first step will be to replace every x I see in this equation by 2. That will allow me to figure out what a is. Once that's done, I'll replace all the x's I see in this equation by negative 2, which will allow us to figure out what b is. Here's what I mean. So I'll start by saying let x equal to 2. Okay, well if I do that, replacing every x by 2, that becomes 3 times 2 plus 7 equals to a times 2 plus 2 plus b times 2 minus 2. And now looking at this term here, I'm sure you can appreciate that since 2 minus 2 is equal to 0, this entire term disappears since the whole thing is just equal to 0. We're therefore left with 3 times 2 plus 7 on the left-hand side, which is just 13. And on the right-hand side, well, we'll have 2 plus 2, which is 4 times a. In other words, we have 4a on the right-hand side. Finally, dividing both sides of this equation by 4, we can state that a is equal to 13 over 4. And we've now found a. I carry on, and I'll make a little line of separation here. And this time I want to find b, so I'll make sure that this term disappears, which I do by replacing the x I have here by -2. So let's go ahead and do that. I'll quickly write let x equal to -2. There we go. And so replacing every x I see in this equation by -2, it becomes 3 times -2 plus 7 on the left-hand side, and on the right-hand side we have a times -2 plus 2 plus b times -2 minus 2. Okay, well, -2 plus 2 is equal to 0, so this first term here will just be equal to 0. And so we're left with 3 times -2 plus 7 on the left-hand side, which is just 1. And on the right-hand side, well, we have -2 minus 2 times b, so that's -4 times b. And so I'll write that, that's -4b. Finally, dividing both sides of this equation by -4, we quickly find that b is equal to -1/4. And that's the value of b. So finally, going back to the result that we had written up here, we can now state that 3x plus 7 over x minus 2 times x plus 2 is equal to, so we had a over x minus 2, which becomes 13/4 over x minus 2. Let me quickly write that. That's 13/4 over x minus 2 plus b over x plus 2, so that's -1/4 over x plus 2. But of course we shouldn't stop here with a 3-level fraction here. Indeed, this is equal to 13 over 4 times x minus 2 plus this fraction, which has a negative numerator, so that becomes -1 over 4 times x plus 2. Finally, distributing those 4's across those two denominators, we can state that that's equal to 13 over 4x minus 8 minus 1 over 4x plus 8. And as such, that's the final answer, which I could go ahead and box like this. There we go. We've successfully carried out the partial fraction decomposition of this fraction. Okay, let's look at this second example. For this second example, we're given the fraction 7x minus 1 over x squared plus 2x minus 3. Once again, we notice that the degree of the numerator is less than the degree of the denominator, and so provided we can write this quadratic in factored form, in other words, provided this quadratic has 2 linear factors, we'll be able to carry out the partial fraction decomposition. So let's see. Focusing on the quadratic we have for a second, we have x squared plus 2x minus 3. Since the leading coefficient, which is the number multiplying x squared, is 1, we can seek to write this in factored form by looking for two numbers which add up to the middle coefficient, so 2, and whose product is -3. And that doesn't take us too long. Indeed, we notice that 3 and -1 work perfectly, so we can write this in factored form as x plus 3 times x minus 1. And so using this, we can state that this fraction is the same as 7x minus 1 over x plus 3 times x minus 1. Now, just as we did in the previous example, we'll go ahead and state that that's equal to some number a over x plus 3 plus another number b over x minus 1. Next, we multiply both sides of this equation by the product x plus 3 times x minus 1, and I'll quickly write that. That's times x plus 3 times x minus 1, which leaves us with 7x minus 1 on the left-hand side, and on the right-hand side, well, this a over x plus 3 times x plus 3 times x minus 1 leads to a times x minus 1, and for the second fraction, we have b over x minus 1 times x plus 3 times x minus 1, so the x minus 1's cancel out, and we're left with b times x plus 3. All right, now looking at all of this, the first thing we'll do is find a, and for that we'll replace all the x's by -3, since that would make this entire term equal to 0. And so I'll write that here. I'll let x equal to -3. There we go. Okay, so replacing all the x's by -3, this becomes 7 times -3 minus 1 on the left-hand side, and that will equal to a times, in parentheses, -3 minus 1, plus b times, in parentheses, -3 plus 3. Just as we said, this term here will equal to 0, So I can cross that out. That's equal to 0. And we'll be left with 7 times negative 3, which is negative 21, minus 1. So that's negative 22 on the left-hand side. On the right-hand side, we have a times negative 3 minus 1, which is just negative 4a. Finally, dividing both sides of this equation by negative 4, we can state that a is equal to negative 22 over negative 4. In other words, a is equal to 11 over 2. And I'll go ahead and box that result. Okay, now we need to find what b is, so I'll make a little vertical separation line there. And I'll go ahead and say let x equal to, well, let's see, looking back at the equation we have here, we want to make this a term equal to 0, and clearly we'll achieve that if we let x equal to 1. So I'll go ahead and say let x equal to 1, and I'll quickly underline that, there we go. And so let's see, replacing x by 1 in this equation, it becomes 7 times 1 minus 1 on the left-hand side, and on the right-hand side we have a times 1 minus 1 plus b times 1 plus 3. I carry on. On the left-hand side we have 7 times 1 minus 1, which is just 6, so we have 6 equals to a times 1 minus 1, which is a times 0, so this term here is equal to 0, plus b times 1 plus 3, in other words, 4b. Finally, dividing both sides of this equation by 4, we can go ahead and state that b is equal to 6 over 4. In other words, b is equal to 3 over 2. And we've now found b. And so going back to the equation that I'm hovering over right now, we can now state that 7x minus 1 over x plus 3 times x minus 1, which we could in fact also write as x squared plus 2x minus 3, which was the original fraction we were given. So perhaps I'll do that here. That was x squared plus 2x minus 3. Well, that's equal to a over x plus 3, so that's 11 over 2 over x plus 3. So that's 11 over 2 over x plus 3, plus b over x minus 1, which becomes 3 over 2 over x minus 1. Now again, we don't stop there. Indeed, we can go ahead and state that that's equal to 11 over 2 times x plus 3, plus 3 over 2 times x minus 1. And so finally, distributing these 2's across those pairs of parentheses, we can write our final answer as 11 over 2x plus 6 plus 3 over 2x minus 2. And that's the final answer. And so I'll quickly box that. There we go. Okay, let's look at one last example. Here we're given the fraction 3x squared plus 5x minus 2 over x cubed minus x. And looking at this, we notice that the numerator is of lesser degree than the denominator. So, provided we can write the denominator as a product of linear factors, we'll be able to carry out partial fraction decomposition. So, let's see. In the upper right-hand corner here, I'll quickly look at x cubed minus x. And looking at this, hopefully you'll appreciate that there's a common factor here. We can just write this as x times x squared minus 1. Furthermore, x squared minus 1 can be thought of as the difference of two squares, so we can quickly write this as x times x minus 1 times x plus 1. And so we've now written this as a product of three linear factors. And if it helps, you can think of the x that we have at the front here as x minus 0. Okay, now that we've got this result, we can go ahead and state that this entire fraction is the same thing as 3x squared plus 5x minus 2 over x times x minus 1 times x plus 1. And so following the pattern that we had in the previous two examples, we can go ahead and state that this should equal to some number a over x plus another number b over x minus 1 plus a third number c over x plus 1. All right, now don't let the fact that we have three fractions here intimidate you in any way. The method is still the same. And so the first thing we'll do here is multiply the entire equation by the product of these three linear factors. In other words, we'll multiply the entire left-hand side by x times x minus 1 times x plus 1, and we do the same on the right-hand side. So this whole thing becomes 3x squared plus 5x minus 2 on the left-hand side, and on the right-hand side, well, we'll have the following. A over x times x minus 1 times x plus 1, which becomes a times x minus 1 times x plus 1, plus b over x minus 1 times x minus 1 times x plus 1, in which case the x minus 1's will cancel each other out, and we're left with b times x plus 1. Finally, multiplying c over x plus 1 by this product, we'll be left with c times x minus 1. Okay, the next thing we have to do to find a, b, and c is replace the x's we have in this equation by the values which will successively lead to these terms being equal to 0. And here's the whole idea. Looking at the term containing an a, we notice that the only factor it doesn't have, which the other two have, is x. So to find what a is, I'll go ahead and say let x equal to 0. There we go. Okay, well, replacing all of the x's by 0, on the left-hand side we'll have 3 times 0 plus 5 times 0 minus 2. In other words, we have negative 2. And on the right-hand side, we'll have a times 0 minus 1 times 0 plus 1. But the other two terms, since they both contain x as a factor, well, they'll both become 0. So we can just state plus b times 0 plus c times 0. In other words, both of these can be ignored. This therefore becomes negative 2 equals to a times negative 1 times 1, which is just negative a. In other words, a is equal to 2. And so we now have the value of a. Carrying on, and I'll make a little separation. There we go. To find the b coefficient, I focus on the linear factor that b doesn't have. And it doesn't take us too long to see that's the factor x minus 1. So if I let x equal to 1, x equals to 1, the left-hand side of this equation becomes 3 times 1 squared plus 5 times 1 minus 2, and that will equal to, well, I suppose I could write it all out this time. That will be a times 1 minus 1 times x plus 1 plus b times, so that's b times 1 plus 1 plus c times 1 minus 1. And now hopefully you can see that for the terms containing a and c, the 1 minus 1's that we have will of course equal to 0, so the entire terms will equal to 0. And so we're left with, on the left-hand side, 3 times 1 plus 5 times 1 minus 2, so that's 6, which equals to the right-hand side where we just have b times 1 plus 1, which becomes 2b. So this whole thing becomes 6 equals to 2b. Finally, dividing both sides of this equation by 2, we quickly see that b is equal to 3. And we now have b. We're nearly there. To find what c is, we focus on the only linear factor that the c term doesn't have, and hopefully you'll appreciate that that's the x plus 1 factor that I'm hovering under right now. And so to make sure that that cancels out, I'll let x equal to negative 1, so that this entire equation turns into 3 times negative 1 squared plus 5 times negative 1 minus 2, and on the right-hand side we'll have a times negative 1 minus 1 times negative 1 plus 1 plus b times negative 1 times negative 1 plus 1 plus c times negative 1 times negative 1 minus 1. And now looking at the terms containing a and b, hopefully you can appreciate that the negative 1 plus 1's that we have here will of course be equal to 0, and so those entire terms will equal to 0. So that's 0 and that's 0. Now on the left-hand side we have 3 times negative 1 squared plus 5 times negative 1 minus 2, which becomes 3 times 1, which is 3, minus 5, so that's negative 2, minus 2, which leaves us with negative 4 on the left-hand side, and that will equal to, well, on the right-hand side, all we have is c times negative 1 times negative 1 minus 1. So that's c times negative 1 times negative 2, which becomes 2c. Finally, dividing both sides of this equation by 2, we can state that c is equal to negative 2. And we now have c. And so using these three results, we can now state that the fraction we were given, so 3x squared plus 5x minus 2 over x cubed minus x, is equal to a over x, so that's 2 over x, plus b over x minus 1, so that's plus 3 over x minus 1, plus c over x plus 1, so that's plus negative 2 over x plus 1, which we can just write as minus 2 over x plus 1. And that's the final answer. And there we go. That's how we can carry out partial fraction decomposition of one polynomial divided by another, provided the polynomial on the numerator is of lesser degree than the polynomial on the denominator, and provided the polynomial on the denominator has real roots and can be written as a product of its linear factors. All that being said and done, that's it for this tutorial.